In section 2, we are going to talk about performing significance tests for population proportions. So to kind of introduce the topic, we're going to look at kind of an example of how a significance test works. So suppose in a class you're going to be shooting a ball into a garbage can, and you have a student, Bob, who claims that they can make 8 out of 10 shots into the can. And we want to test this claim. We want to know how likely this is to happen, which is where a significance tests come in. So our first claim is going to be that the proportion that he makes is 0.8, because 8 out of 10 is 80%. And as a class, we decide Bob's full of it. He can't really make 8 out of 10. So our second claim is that the proportion is actually less than 0.8. So these claims are called hypotheses. And then to test to determine which one we will accept is called a significance test. So our first claim, which is that P is 0.8, is called our null hypothesis, which is H naught. So that H with the subscript of 0 is pronounced H naught. So this is a claim made by someone or something with a statement of no difference, that our claim is basically accurate. Our second claim, that P is less than 0.8, is called our alternative hypothesis, HA. And this is the claim we are trying to find evidence for. We are always trying to find evidence for our alternative hypothesis to show whether or not it's true. So let's suppose Bob shoots 10 times, and we get a sample proportion, so a p hat of 0.6. So unfortunately, Bob did not make the reported proportion that they claimed. So a couple questions we kind of think about is, what exactly is the claimed proportion? Was it exactly the claimed proportion? And the answer is no. Now, can it be that the sample proportion and their claimed proportion still be correct? And the answer is possibly. Could it just been that Bob was having an off day or got distracted? Who knows? So we want to know, how can we decide if the difference is due to chance variation or if the original claim is incorrect? And what we do is we test to see if the difference between the two is significant, is due to chance variation, or if the original claim is incorrect. So the first thing we're going to talk about is how we set up a hypothesis test. So the first type of hypothesis test is a one-sided hypothesis test. So that means you are specifically looking in one direction for your alternative hypothesis. So for the first example, your null hypothesis is that the proportion is 0.7 and your alternative is that it's less than 0.7. Or you could potentially have a null hypothesis of the proportion being 0.2 and your alternative is that it is greater than 0.2. So we're only looking in one direction. Either it's less than or greater than the null hypothesis. And these are called one-sided hypothesis tests because we are looking at one side of the null hypothesis. So couple things is that the null hypothesis is always going to be set up as equal to. And the alternative hypothesis is above or below that same value. So you should always be using the same proportion in the null and the alternative hypothesis. And the hypotheses are based on a population parameter P, not your P hat. They are always based off your population parameter. The second type of test is a two-sided hypothesis test. So that's when your alternative hypothesis does not equal. So you're not specifically saying, oh, I think it's less than or greater than. You're just saying, I don't think it's 0.7. So it's two-sided because we're not sure in which direction it could be different. It could be greater than, it could be less than, we don't know. Very important thing is that hypotheses are always developed before a study is conducted, and we do not adjust our hypotheses after we have already gathered data, because then your results are biased and they can't be interpreted correctly. So our data will be above or below the claim, but if we started off not knowing which direction the data would trend, we have to keep running the test anyway, because next time it could trend in the other direction. So when we're performing a significance test, we're asking the question, how likely is it to get a result like this just by chance when the null hypothesis is true? And the more likely it is versus the less likely it is allows us to reject or fail to reject our null hypothesis. So let's go ahead and look at another example. We have Zach, who is an 80% free throw shooter. And if Zach is really an 80% free throw shooter, we want to know, is it possible for him to shoot 50% in one game? So we could actually find the probability of this happening, and it's the probability that Zach shoots 0.5 given he is an 0.8 shooter. Okay? So if we get a low probability, then that is good evidence that the null hypothesis is not true. So if we get a low probability, then it tells us that he is not a 0.8 shooter. So the probability of the event occurring given an original claim is called the p-value. And the p-value is going to help us to determine whether or not we reject or fail to reject our null hypothesis. So for the official definition, the p-value is the probability computed assuming your null hypothesis is true, that your statistic, p hat, would take a value as extreme or more extreme than the one actually observed in the direction specified by your alternative hypothesis. So it really just depends what your alternative hypothesis is. So it's a value as extreme, more extreme, not the same as, depends on what your alternative hypothesis is. So to calculate our p-value, we use our sample statistic, p hat, and our null hypothesis. And we're going to be calculating z-scores to determine the difference between what we observed and what our claim is. And then we'll calculate the probability that we would get this value or something more extreme in the direction of the alternative and make a decision on if that probability is low enough that we can say it is unlikely to occur by chance. And that value is set by a significance level. That's how we determine if a probability is low enough, is by having something called a significance value. Okay. So for a significance value or a significance level, the significance level is denoted by the Greek letter alpha. And it is also something that is set before a test is performed. And choosing it is based on a few factors, which we'll discuss later. But it is always given in a problem, or it's going to be something that there's a specific alpha that we'll use when it's not stated. So if our p-value is smaller than alpha, which as an inequality, so p-value is less than alpha, then we say that the results of the study are statistically significant. So what that means is that the probability of this event occurring by chance is so low that it is not due to sampling variability. And in that case, we reject our null hypothesis and conclude that there is convincing evidence in favor of the alternative. So if you get a very, very small p-value, it means that the probability that you got that p-hat is not due to sampling variability, that it really isn't, the claim that we made isn't really accurate. So on the reverse side of things, if our p-value is larger than alpha, so p-value is greater than alpha, then we say the results of the study are not statistically significant, which means the difference between p and p-hat can be attributed to sampling variability. So in this case, we fail to reject our null hypothesis and conclude that there is not enough convincing evidence in favor of the alternative. So we don't actually accept our null hypothesis as true. We are either rejecting it or failing to reject it. We're never going to say that we accept the null hypothesis, because all we showed is that we do not have enough evidence against the claim. We did not actually prove it as true, which is a very important distinction when we're talking about a significance test. So let's talk about some very commonly used alpha levels, so significance levels. So there are three very, very common ones. One of them is that alpha is 0.01, 0.05, or 0.10. So what that means is we're looking at the probability of something being 1%, 5%, or 10% in that direction. And we'll talk about what this looks like for each of our types of tests. So we're going to start with our two-sided hypothesis test. So in our two-sided hypothesis, we have our null hypothesis that our proportion is equal to what we call P naught, which is whatever our claim is, and our alternative hypothesis that the proportion does not equal P naught. So the way to kind of explain how this works is through a picture. So we're going to have our normal curve, and we have that our null hypothesis P naught is in our center. And our P hat, because we're not looking in any specific direction, is either going to be above or below. We don't know which. And there is a probability it falls either above or below that P naught. And because we're not looking in any specific direction, this combined area is our p-value. So the area is the probability it's above or below. And again, we don't know which. Next, we're going to look at our one-sided hypothesis tests. So the first one we're going to look at, so our null hypothesis is always P equals P naught. Our alternative hypothesis is going to be that P is less than P naught. So when this happens, still have our normal curve, we have our P naught, but in this case, our P hat is less than. So our P value is just the shaded area below. And for our other one, so null hypothesis, P equals P naught, the alternative that P is greater than P naught, still have our curve, we have our P naught. This time our P hat would be above it, and we just have one area for our P value. So we're finding the area or the probability we get a P value that we have. So just like sampling distributions and confidence intervals, when we are performing a significance test, we have to follow our four-step process. So the first thing you want to do is state your null and alternative hypotheses. That way you know what you're trying to find evidence in favor of. Secondly, you're going to check your conditions. Random, independent, and normal, the same that they've been for proportions in the previous section and in chapter 5. Next, you're going to calculate your test statistic so you can find your p-value. And then lastly, you're going to compare that p-value to alpha to make a decision, whether or not you're rejecting or failing to reject, and then writing your sentence. So let's talk about how we calculate that test statistic, our z. It's very, very similar to how we calculate a z-score from before. So for our test statistic, we'll have z equals. We'll take our p hat and subtract our p naught, so whatever our hypothesis is, over the square root of p naught times 1 minus p naught all over n. So when we calculate the standard deviation, we use the proportion from our null hypothesis, what we are claiming it to be. We do not use our p hat. So this is where it kind of is going to differ a little bit from a confidence interval where we always used p hat when we calculated our standard error. When we do a significance test, we're actually going to use the null hypothesis proportion. Okay. So when we do this, we find our p-value by calculating the probability of getting a z statistic that large or larger in the direction specified by the alternative hypothesis. So if your alternative hypothesis is that p is less than p naught, you have your normal curve. Your mean is now going to be 0 because we've normalized it. Your z-score is going to be negative because it's below the mean and our area is the area below. If your alternative hypothesis does not equal, mean is still 0, but our z-score could be positive or negative. We don't know which ahead of time. And it could be the area above, it's the area above or the area below combined. And then lastly, if your alternative hypothesis is greater than, mean is 0, our test statistic would be greater because it's above, and our area is the only thing above. So it's very, very similar to what we were looking at when we're talking about where p hat falls in relation to our null hypothesis. So let's go ahead and do an example. So Alan reads a report that says 80% of U.S. high school students have a computer at home, and he believes the proportion is smaller than 0.8 at his high school BHS. So Alan chooses an SRS of 60 students and records whether they have a computer at home. And he wants to test this at a 5% significance level, and in his SRS, 41 of the students have a computer at home. So we're going to start with our null and alternative hypotheses. So our null hypothesis is based off the claim, which is that the proportion of students who have a computer at home is 0.80. So P equals 0.8. Our alternative hypothesis is based on the wording of the problem. So Alan believes the proportion is smaller than 0.8. So that tells me my alternative hypothesis is that P is less than 0.80. Now we're going to check our conditions. So for random, it is stated that we are taking an SRS. So we've met that condition. For independent, our sample size of 60 is less than or equal to 10% of all U.S. high school students. Because again, there's at least 600 of those, and some high schools have more than 600. And then lastly, we have normal. So we are going to be using our population proportion here from our null hypothesis, and we're not going to be using p hat. So another difference from a confidence interval. So we need to check that 60 times 0.80 is greater than or equal to 10, and 60 times 0.20 is greater than or equal to 10. So 50% of 60 is 30. So 80% is definitely greater than or equal to 10. The only one that I might have a little bit of problem with is 20%. And 60 times 0.2 is 12. So just barely, but is greater than or equal to 10. Okay. Next, I want to go ahead and identify my p hat. We know that 41 out of the 60 students say they have a computer at home, which is going to give us 0.68 and then 3 repeating. So we're going to have 0.68. So next I'm going to use that to calculate my z-score. So we're going to do 0.68 minus 0.80 all over, and then our standard deviation, the square root of 0.80 times 0.20 all over 60. So 0.68 minus 0.80 is going to give us negative 0.12. The square root of 0.8 times 0.2 over 60 is going to be 0.0516. So when I divide those, we're going to get a z-score of negative 2.32. It is preferred that you try to do the z-score all in one step, just so we are not rounding too much and we get the most accurate z-score as possible. Okay, now to find my probability, I'm going to use normal CDF. So because my alternative hypothesis is less than, my lower bound is negative 1e99. My upper bound is negative 2.32. We're going to plug in our mean of 0 and our standard deviation of 1. And we're going to end up with the probability 0.0102. So in a sampling distribution, this is where I would stop and talk about how likely or unlikely it is to get your sample proportion. But now we're actually going to test whether or not the claim is true or not by comparing that to our alpha. So we now have a p-value, which is 0.0102, and we know our alpha, stated in the problem, is 5%, which is 0.05. And I'm now going to compare those. And 0.0102 is less than my alpha of 0.05. And whenever that happens, we reject our null hypothesis. So we're going to reject H naught. And then we're going to write our sentence. So we're going to start our sentence with there is, and then if you reject, we say there is evidence. If we are failing to reject, we say there is not enough evidence. So there is evidence to show the true proportion of U.S. high school students who have a computer at home is less than 80%. The only other thing I want to cover here is how to perform a significance test in your calculator. So everything I just did when I calculated my z-score, I used normal CDF to calculate my p-value. That is one option. But to avoid rounding, there is a second option. And that second option is if you go to Stat and then Tests, you're going to go to number 5, which is a one prop z-test. And what it does is it performs a significance test for one proportion. So you need 4 things. You need your p naught, which is your null hypothesis, which in this case is 0.80. You need your x, which is the number of students who have a computer at home, which is 41. You need your n, which is your sample size, which is 60. And something called your proposition, which is your alternative hypothesis, which in this case is less than p naught. So then you hire that one. And then you hit calculate. So it's going to give you your z-score, your p-value, your p-hat, and your n. So in this case, my z-score is just a slightly more accurate. I get a z-score of negative 2.26 because I had to round twice when I was calculating my z-score. I rounded once when calculating my p-hat, which wasn't exactly 0.68. And I rounded when I calculated my standard deviation, which gave us a not as accurate z-score. And then my p-value, which they do use just p for p-value, my p-value ends up being 0.0112, which is also a little bit bigger, so it is different than what we calculated. Not significantly different that it changes our conclusion, because when I compare 0.0112 to 0.05, it's still less than alpha. We're still going to reject our null hypothesis. So whichever method you choose is never going to be different enough that it would change whether or not you reject or fail to reject the null hypothesis. But if you want to be a little bit more accurate, you can use the calculator to get your z-score and your p-value. But I still require that you at least set up the formula for this test statistic so that I know that you understand how it was calculated to get the p-value. So let me know if you have any questions about how we perform a significance test for a proportion.